Okay, so we're going to have a look at dependent probability. Okay, so imagine that I've got a bag of sweets. Let's say that we've got 6 colour bottles and 4 strawberries. Okay, and I'm going to take 2 sweets. From the bag. Now, as soon as you take a sweet from the bag, the probability changes. Okay, so if I start off at the minute in my bag, okay, colour bottles, I've got 6 out of 10, okay? There's 10 sweets in total, there's 6 and there's 4, so my probability is 6 out of 10. My Strob's probability is going to be 4 out of 10. Okay, yes, I could simplify these. I'm not, just because when you see what happens, it makes it a lot easier. Okay, now I'm not just taking 1 sweet, I'm taking 2. Okay, so what I can do is I can put this into a tree diagram. And this is the easiest way to really deal with dependent probabilities. You can do other things with them, but I really recommend for these type of questions that you use a tree diagram. So if I start off, my first selection of then cola or Strob's, I've got the probabilities that I had from before. So if I look back to before, I said 6/10 and 4/10. Okay, and this is the probability of my first pick. Because if you imagine, I'm putting my hand in, I'm picking one out, and then I'm going to do it again. Now, as soon as I've taken one of these out, the probabilities will change. Okay, if I've taken out a cola bottle, okay, if I've taken out a cola bottle, well, let's think about the probabilities, okay? So if I've got a cola bottle, so we said cola bottles started with 6 out of 10, okay? So there were 6 altogether. Now, if I've taken a cola bottle out, actually, I'm doing 6 minus 1. I'm going to have 5, okay? Because I've got this minus 1 here, I'm also going to have to minus 1 from the total number of sweets because I've taken out a sweet. So I've got 10 minus 1, which gives me 9. So what I actually end up with is the probability of 5 over 9. Okay, so what happens here for my cola is I now have 5 over 9 rather than 5 over 10. Okay, because we've taken a cola bottle out. So we've got to account for it in our bottom number, in our denominator, but we've also got to account for it in the top number, okay, in our numerator. Because we're saying that actually there's only 5 cola bottles now in the bag, and there's 9 sweets in the bag altogether. Now, the way to work out Strob's, you can do it in a couple of different ways. You can think about, well, what's here, it's not changed, or remember that these two things must add up to 1. So if this is 5/9, then this one must be 4/9, so that it adds up to 1. Again, I can think about the fact that actually Strob's hasn't changed. It's still exactly the same. So I'm just keeping that 4. The only thing that's changed is how many sweets are in the bag. Okay, and this is my second pick. I know it seems a little bit strange. People often get confused with the fact that when it says pick 2, they almost do a third section. But what we're saying is this was pick number 1. This was the original probabilities in the bag. And then this becomes our second set of probabilities. Okay. Now, if we have a look at the other option, imagine I picked a Strob instead. Okay. So I started off with my Strob's. And we said that we had 4. Okay. And we had 4 out of 10. Okay, so I have 4 Strob's altogether. Now, if I've taken out a Strob and eaten it, I'm doing 4 minus 1, which gives me 3. Okay, equally, my top value, I'm going to do 10 take away 1, and that's going to give me 9. So what I'm now left with is 3 out of 9. Okay, so I've now got this probability for Strob's that is 3 out of 9. Now, again, equally, I can look at this bit to get this other one for cola bottles, or I can think about, well, it's got to add to 1. It's got to add to 9 out of 9, so this must be 6 out of 9. So again, with the Strobs, the numbers changed on the top because I've taken 1 out. The numbers changed on the bottom because I've taken 1 out. But with the cola bottles, because I took a Strob to start with, actually there's no difference here. Okay, there's no difference in how many cola bottles I have. Now, this is what makes it dependent, because actually you can see each of these probabilities are different depending on which one you take. And that's what makes it a dependent probability, okay, because it's dependent on the first thing. And if you think about it, okay, yes, you can do tree diagrams where there's replacement and you put it back. You're not going to go into your bag and hook out a sweet, eat it and put it back. You can't do that, okay? Once you've eaten it, once you've taken it, it's gone. And that's why we use these dependent probabilities. Now, what I can do is I can do different calculations with these as well. Okay, I can work out my probability of cola and cola. So to do that, I'm multiplying along the branches. So I'm doing 6 out of 10 times 5 out of 10. That's really annoying me. Okay, and so I would end up with 30 out of 90. Okay, equally I could work out my probability of cola and then a Strob. So I'm doing 6 out of 10 at this time, and then I'm going across to here, times by 4 out of 9. So I'm now going to have 24 out of 90. Okay, I could equally do it for the other two. So Strob and then cola. So I've got 4 out of 10 times 6 out of 9. So I'm going to have 24 out of 90. This may not always be the same. Quite often they are. Just be warned if it doesn't always turn out that way. And then I've got probability of Strob and Strob. So I've got 4/10 times 3/9. Okay, and then that would give me 12 out of 90. And the thing I can do to check, does it actually work? If I add those all up, they give me 90 out of 90. So they should add up to 1. And if they don't, that's where you need to go back and check actually what's happened, things like that. So if it asks me any questions, then I can use this, okay? I can use this because it might say something like, what's the probability of getting two the same? Okay, so that's quite a common thing. They say something like the probability of two the same. Now, in that case, I could have the probability of cola and cola. And I could also have the probability of Strob and Strob. So what I've got to do here is add them together. So I've got my 30 over 90. And I've got my 12 over 90. And I add them together and I get 42 out of 90. Now, obviously, with all of these things, I'm not adding them together, okay? I'm not actually, no, I am adding them together. I'm not simplifying them. At the end of a question, you should simplify. I'm only not simplifying them just to show you what actually happens. Please don't simplify at this point. Do not simplify until you get to this bit here where it says something like 42 over 90. Otherwise, it just gets more confusing. But if you take that process of, okay, I'm going to work through, I'm going to minus 1 from both of these to get this, then how does it add up to 1? And then the same on this one, I'm going to minus 1 from both to get that, and how does it get to 1? You will be able to do these questions. Okay, so have another go at the exercise, see how you get on, and ask if you have any other questions. Bye.